Tabria needs to construct a cylinder from a single sheet of metal with a perimeter of 2,652 millimeters. Determine the dimensions of a sheet of metal such that the cylinder created with it is of a maximum volume. Okay, so we're going to maximize our volume equation. So let's go ahead and write down our volume equation. Volume of a cylinder is V is equal to, it's going to be a circle on the bottom and then multiplied by the height. So it's going to be pi r squared h. That's our volume equation. We're going to replace some of these variables here. We'll call this an r value. We don't know what that is yet. And our height is now going to be the letter y. So volume equals to pi r squared y. They also told us that the perimeter of our rectangle here has to be 2,652. So the perimeter is made up of the four sides. So we can see it's 2 x's and 2 y's. So the perimeter equation is 2x plus 2y. And then this is going to equal to 2,652. So we also need to find the r now. The r in the equation is going to be the rolled up section of the x value. So that is their circumference. So 2 pi r is our equation for circumference. And that's going to be equal to our x value. So our r is equal to x over 2 pi. Okay. We can then we can have a x value go here, but then we need to solve for our y value so we can get the same variable. It'd be nice if we could keep it as y, but there's no relationship that we can bring over. So let's go ahead and solve for our y using this equation here. So y is equal to, or 2y is equal to 2652 minus 2x, and y is equal to, let's go ahead and just divide it. It'll be 1, 3, 26 minus x, right? And that'll save us a little bit of time. So our volume equation is going to be pi r, where it's going to be x over 2 pi squared, and our y value is going to be 1326 minus x. All right, so we wrote everything in one variable, and let's go ahead and take the derivative. The way we maximize an equation is by taking the derivative and setting equal to 0, looking for critical points. So v prime, actually no, that's actually, let's multiply it out. So v is equal to pi x squared over 2, that becomes a 4, let's get a 4, pi squared. So we're going to divide one of those pi's out, and then let's go ahead and distribute again. So we have our velocity, our volume is equal to 1326 x squared over 4 pi, and then minus x cubed over 4 pi. Let's bring the 1/4 pi out. The volume equation is 1 over 4 pi. And we have 132.6 x squared minus x cubed. Okay, let's take the derivative of this. Since we have a constant multiple of 1 over 4 pi, we'll leave that alone. 1 over 4 pi. And then let's go take the derivative inside. The 2 comes down, right? Power rule. And that'll be back to our original 2652 x minus 3x squared. We're going to make this equal to 0, look for the critical points. So pretty much this has to go to 0, that's just a constant. So 2652 x minus 3x squared equals to 0. Let's factor out the x. 2652 minus 3x equal to 0. So we have critical points at x equals to 0. and 2652 minus 3x equals to 0 also. Let's solve for x on our right side. Negative 3x equals to negative 2652. Let's divide by 3 to both sides. X, negative 3 to both sides. That becomes a 8. 25 is 24, remainder 2. 25 is another 8. And then remainder 12 is a 4. Okay, so we have our x value. Now we can use that to solve for our y value. We have our equation over here, solving for y. So y is equal to 1, 3, 2, 6. We're going to minus our 8, 8, 4 from our x value that we solved for. And that gives us 442. That's going to be millimeters.